Hello AAT, this is section 3.5, Finding and Using Roots. Here we're going to talk about the rational root theorem. Rational root theorem, which you saw in Algebra 2. Some people like to call it the P's and the Q's because we use those to find our factors. If a polynomial has integer coefficients, then all potential rational zeros are included in the list of numbers where P over Q equals the factors of the constant term over the factors of the leading coefficient. Now, wow, that's a bunch of mathy words and sounds really scary, but all this means we've been talking about finding roots and zeros, which are our x-intercepts and are so handy, and how we factor something and set it equal to 0 to find those roots. However, sometimes things can't be factored, and this is what we do when we want to find a root that's rational, which means it can be written as a fraction. So this does not include imaginary numbers, and it doesn't include irrational numbers, which are decimals that just go on and on and on and on, like the square root of 2 or the square root of 7 or pi. So first we've got to find out what the possible rational zeros are, and then we're going to figure out which ones actually work. So we're going to call this final number a constant term, and that's only when these things are listed in decreasing order like they should be, and your leading coefficient, we've talked about what that is before, what the number in front of that highest term, we're going to call Q. So the factors of 2 is going to go on top, that's our P, and our factors of 1 is our Q, that's going to go on bottom. So factors of P, what will go into 2? Well, only thing that'll go into 2 is 2 and 1. But we're talking about positive 2 and negative 2 and positive and negative 1. So there's 4 possibilities on top. And then on the bottom fractions, well, we can have positive 1 or negative 1. Now this does not make sense as a number, so please don't leave it like that. We're going to make all possible fractions out of these numbers. So we have positive 2 over 1 and positive 2 over negative 1. So that gives me plus and minus 2 as possibilities. If I do negative 2 out of those two things, I'm going to get the same two numbers. Then I have 1 over 1 and 1 over negative 1. So my possible rational roots are plus or minus 2 and plus and minus 1. There's 4 possible ones, and then we're going to figure out which ones actually work. So for B, so P is 12 and Q is 3. So the factors of P, factors of the last term over the factors of the first term. So what will go into 12? Well, there's a lot of them. There's plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, 6, and 12 will all go into 12. And what will go into 3? I'm going to put a dotted line because I don't want to make this actually look like a fraction. Factors of 3 are plus or minus 1 and plus or minus 3. So all possible fractions of those. So if I put 1 on top, I have 1, 1 over 1, and 1 over 3. Now these are all going to be plus or minus, so I'm going to just put a big plus or minus out in front. If I use 2, I have 2 over 1, which is 2, and 2 over 3, 2/3. If I use 3, I have 3 over 1, and 3 over 3, which is 1. I've already got that one. 4 over 1, and 4 over 3. 6 over 1, which is 6, and 6 over 3, but that's 2, and I've already used that. 12 over 1. And 12 over 3, but that's 4, and I've already used that. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. And since it's plus and minus, that's actually 18 possible rational roots. Okay, so you try C and D and see if you can come up with our list of possible rational zeros. Okay, and here are our answers for C and D. The first one, we have P is 10. And Q is 2, so all possibilities of 10 over 2 and their factors. and we get this list. I put them in little set brackets, which means these are all my possibilities. But I have a plus and minus, so there's really twice as many as I see. Notice that when 1 is my P, just like on A, I really only have to look at all the factors of, when 1 is my Q, 1 is my leading coefficient, I really only needed to look at the factors of 40. Because 40, 20, 10, 8, 5, 4, 2, and 1, if you put them over 1 or -1, you end up with those same numbers. So there's my list for the second one. Okay, so once we have our list of possible roots, what do we do with them? Notice the difference when it says all the roots. If I ask for the possible roots, you're done when you find this list. But if we actually ask to find all the roots by using synthetic division, then write the equation in factored form, that means we're going to bring it all the way down. So we start out with getting our list. Now this equation, notice, is the same equation as we did in D. So we already have our list of possible rational roots, and sometimes we'll just call those PRRs. Our PRRs are 40, 20, 10, and so forth. So now we're going to synthetically divide by those and see which one is a root. Now remember, if you synthetically divide when the remainder equals 0, then you know that it was a factor that you have a root. So I often start with 1 or -1. I can usually plug in 1 really quick and see whether or not it works, but I can see 1 minus 7 plus 2 plus 40 is not going to be 0, so 1 isn't going to work. So I might try -1 or 2 to start. Let's start with 2. If I synthetically divide by 2, by 1, -7, 2, and 40, remember if you skip any terms to put a 0 in, I'm going to put my line, synthetic division, I drop the first number, that's a 1. 2 times 1 is 2. -7 plus 2, remember you're always combining here, not subtracting like long division. 2 times -5 is -10. That gives me a -8. 2 times -8. Wait, did I do that right? Yeah. 2 times -8 is -16, and I can see that is not 0, so 2 is not going to work. So I need to try something else. So I'm going to try -2. And so this could take a while. When you have a long list, we're gonna divide by every one of these until we get a 0 as the remainder. But this is not the 0 remainder. I didn't have to finish it off. I just can see that that's not 0. So drop my 1. -2 times 1 is -2. -2 and -7 is -9. -2 and -9 is 18. 2 and 18 is 20. -2 and 20 is -40. Yay! And that gives me a 0 is a remainder. When the remainder equals 0, then x equals -2 is called a 0 or a root or an x-intercept since it's real. So what do we know? Well, we know that x plus 2 is our first factor because -2 is the root, x plus 2 is the factor. Now, I have stuff left here. This is where we get a depressed equation. This started out with a cubic, and we divided out 1x, and so now we have knocked it down to a squared. It's gone down a degree from cubed to squared. So if I take these coefficients, now I have x squared minus 9x plus 20. Oh, isn't that nice? And I can factor this or do quadratic formula and get my last two roots or factors. And I know I have 3 because it's cubic. So this does factor. Two things that multiply to be 20 and add to be 9. I know it's x minus 5 and x minus 4, which would give me roots of x equals 5 using the zero product property and x equals 4. So be careful when you're listing your zeros. Make sure you list all 3. Sometimes people forget that first one. And when you put it in factored form, it's x minus 5 and x minus 4 and x plus 2. It's the opposite sign as the zeros. Okay, so this is the factors. These are the zeros or roots. Don't get that mixed up. Excellent. Okay, now find the rational roots of b, which is, well, find the ones for b and then come back and check. Make sure you synthetically divide to find all of the roots. Okay, so let me show you. I got the possible rational roots on b were plus or minus 3 and plus or minus 3/2. And I synthetically divided by 1, and it was nice. I always try 1 first because that often works. Synthetically divided, I got 1 is as the remainder. So x equals 1 is my first root, and x minus 1, opposite sign, is my first factor. Now be careful here. Remember, when we factor, I took these coefficients to knock it down a degree. That's my depressed equation. And when I factor something with a leading coefficient that's different than 1, remember this is going to be 2x and x. So however, guess and check, slide and divide, you decide which way you want to do. But what multiplies to be 2? 2 and 1. What multiplies to be negative 3? Well, 3 and 1. When I cross 3, 2 times 1 is 2. They need to combine to be positive 5. Well, that looks like that's going to work, but to be a negative 3, one of these had to be negative. So if I make that be negative, then that'd be a minus 2, and it would not add to become 5. So let me try it again. 2 and 1, and let me switch the order. 3 and 1. So 2 times 1 is 2. 3 times 1 is 3. Okay, now if I want to be, oh, wait a minute, I didn't switch the order, did I? I kept them just the same. Try that again. Let's make that a 1 and 3 instead of a 3 and 1. Switching the order different from how I had them before. I was wondering what was happening there. 2 times 3 is 6. 1 times 1 is 1. Now, I wanted a 5, a positive 5 in the middle. So 6 minus 1 would be 5. And this needs to be 1. So that means 2 minus 1 in my first parentheses and 1x plus 3 in my second parentheses. So make sure when you fold them back, 6x minus 1x. There's our last two factors, 2x minus 1 and x plus 3. So if you're asked to put it in factored form, there's the answers. If you're asked for the roots or the zeros, you get 1/2 from 2x minus 1 and negative 3 from this one. And you should have 3 roots because it was cubic. All right. We're going to stop right there and come back and do the